The purpose of this video is to go over the solutions of the practice with representing and simplifying expressions. This was worksheet 22 for pre-AP and worksheet 27 for on-level students, but the content is the same. For problem number 1, it states Ms. Halpern asked each group of students to write an expression equivalent to the model below. And the table shows the group's expressions. Which group wrote an incorrect expression? And there's a lot of simplifying that needs to be done before you can tell who is incorrect. First of all, I see that there are 4, 8, 12 rectangles, and each rectangle represents an x, which means the picture shows 12x, and I see 3, 6, 9 constants. So this picture is showing me the expression 12x plus 9. Now I need to check each group's expression. When I see 3 and a parentheses touching, that means to multiply. 3 times 4 x's would be 12 x's, and 3 times 3 would be 9. This appears to be a match. For group 2, the 4x needs to be distributed to each term inside the parentheses. 4x times 3 would make 12 x's. 4x times 3, another 12 x's. And 4x times 3, another 12 x's. 12x, another 12x, and another 12x. This would be 36 x's. So I do not believe that that one is equivalent. I'll still check the others. For group 3, you have to distribute the 3. 3 times 4 x's would make 12 x's. And 3 times 3 would make 9. And then for group 4, I don't see any parentheses. There's no distributing to do, but there are some like terms that can be combined. I see 4x plus another 4x, that's 8 x's, plus another 4x, that would be 12 x's. And then 3 plus 3 would make 6, plus 3 more would make 9. So the entire list, it appears that group 2 is the only group that was incorrect. For number 2, it says Larissa and Sakara each rewrite the following expression. Larissa rewrites 4a plus 11 plus 3a, and Sakara writes 7a plus 11. Which student wrote an equivalent expression? And to explain. From what I see, I am going to be combining my like terms. A plus a would make 2a's, plus another 2a's would make 4a's, plus 3 more would make 7. Then I can combine the constants together. 7 plus 4 would make 11. So at first glance, it would appear that Sakara wrote the same thing that mine simplifies to, but I also see that Larissa, if I took 4a and 3a and added them together, I would still get 7a plus 11. Sakara's is just a more simplified version of what Larissa wrote, but they are both equivalent to the original expression. For number 3, kind of similar to number 1 with the key, there is an expression that is modeled, and which of the following could not be the expression that was modeled? So personally, I'm going to simplify what I see for everything and see which one is not the same simplified equivalency. 1, 2, 3, 4, 5, 6, 7, 8 x's. 1, 2, 3, 4, 5, 6, 7, 8 constants. So this picture represents the expression 8x plus 8. For A, if I distribute the 2, 2 times 4 x's would make 8 x's, and 2 times 4 would make 8. This appears to be equivalent. For B, I don't see any parentheses or any distributing, but I do see like terms that can be combined. 4x plus 2x would make 6x, plus another one, 7x, plus another one, 8x. And then I see the constant 6 plus a constant of 2. 6 plus 2 makes 8. This also appears to be equivalent. For C, the parentheses touching means multiply. 4 times 2x's equals 8x, and 4 times 2 equals 8. I'm really hoping it's D, or I've made an error. For D, I'm going to combine the like terms together. 3x plus 3x is 6x, plus 3 more is 9x. 2 plus 2 is 4, plus 4 more would be 8. So it is D that is the one that is not equivalent. For number 4, which expressions are not equivalent? I see 2-term expressions and multiple term expressions, which must mean that these are simplified versions of the ones that are given on the left side. So I'm going to begin looking for like terms. On A, I see 3x, and I see these 2 constants. Constants are like items, and they can be combined. 5 and 20 would make 25, and the 3x's was just brought over. That appears to be equivalent. For B, I see an x, and I see constant values. The constants are like terms. 5 minus 2 is 3, and it appears that the x was just brought over. That also appears equivalent. For C, the 2 is touching with the parentheses, which means to multiply, and I can use the distributive property. 2 multiplied with an x would make 2 x's. 2 multiplied with a 5 would make 10. And I'm just going to bring down the plus 6. Now I can keep simplifying, and I observe that I have some like terms right there. They're both constants. 10 plus 6 would equal 16, and the 2 x's, that appears to be equivalent. For D, I see an x minus an x. If you had an x and you took away an x, that would leave you with nothing. They would cancel each other out. And then a plus 5. I see the plus 5, but I also see that it appears maybe somebody was thinking x plus another x to make 2 x's, not x minus an x to make nothing. So D is the one that is incorrect. For number 5, the model is representing the expression 4 times 3 plus x. I can see that because I see 3 plus x, one group, 3 plus x, another group, 3 plus x, another group, and a fourth group, so that's why it's multiplied by 4. Which of the following is equivalent to 4 times 3 plus x? So I could do a few things. I could use the distributive property. I could also use picture illustrations. It does not matter. I'll try to do both. In this picture, I see a total of 4 x's plus 12 constant values. And I'm already wondering if it might be this one. This is missing a 4 with the x. This is missing a 4. This doesn't have a 12. This doesn't have a 12 either. And here the 4 is looking okay, but I'm a little confused about the plus 7. I'll also try it mathematically. If I did 4 times 3, that would equal 12. And 4 times x would make 4 x's. So I'm feeling pretty confident about D, both with the picture and using the distributive property. Number 6, which expression is equivalent to 4y plus 6 plus 2y minus 7? I see 4y and 2y are like terms and they can be combined. That would make 6y's. Already I'm feeling like it might be A and it might be D because those possibilities have 6y as one of the terms. Then I see 6 minus 7. And if I do 6 minus 7, I would go into the negative numbers. I'm pretty sure that it is A, and if you're a little confused about, Ms. Halpern, why are you writing minus 1 when you just said it would be a negative 1? Allow me to illustrate. Going back to the original, this was the original algebraic expression that was given. And we learned at the beginning of the school year that subtracting is the same thing as adding a negative. Imagine in your mind, keep, change, opposite. These two expressions are mathematically equivalent to each other. Then I'm going to do a little bit of rewriting. As you can see, what I have done is I have taken these two terms and I have flipped them. The commutative property says it's fine to switch the order of terms if you are adding or multiplying, and in this case we're adding. So I currently have the original expression, something equivalent to it, and something else equivalent to it. Now my like terms are right next to each other. 4y plus 2y, 6 plus a negative 7 would be a negative 1. And now I'm going to take this knowledge, if adding a negative is the same as subtracting a positive, keep, change, opposite, these are also equivalent to each other. And so I do end up getting A still. A lot of these equivalencies, in my mind, being higher level in my mathematics, I take it for granted, knowing that they're equivalent, but it can be a little tricky if you're new to algebra. But we've talked about number properties and we've been discussing equivalencies all year long, so this is bringing all of that knowledge together and beginning to work more fluidly through the algebra. For number 7, which expression is equivalent to 28 plus 16 plus 12 plus y? I'm going to begin by simplifying what I was originally provided. I don't see any number outside the parentheses that tells me to multiply with it. And the associative property says numbers can be grouped together when you add. They could also be grouped differently like that. It wouldn't make a difference. So I'm going to drop those parentheses off because the entire expression is addition. If I were going to do order of operations, parentheses would be listed first and I would complete 28 plus 16. But since everything is addition, I would be moving through the expression left to right and I would still be doing this first. 28 plus 16 would make 44. And then 44 plus 12 would make 56. I see that D might be an option, but I just want to make sure. Here I see 12 is multiplied with y, but here it doesn't show multiplication. It shows 12 is a separate term plus y being a separate term. It doesn't show 12 being right next to it as a coefficient. Same logic on YB would not work. In fact, even back to A, it appears that y is being multiplied with 12 and being multiplied with 16, and then randomly there's a 29 and not even a 28. So A is wrong for many reasons. For C, I do see the touching the y to the parentheses, which means y would be distributed or multiplied with 28 to get 28 y's plus 16 y's plus 12 y's, but that is not what was in the original expression. Again, y was added, it wasn't multiplied with, which leads me back to D, which I kind of suspected in the first place when I got 56 plus y. For number 8, it says Nathan combined like terms to simplify the expression below. 8k plus 7 plus k minus 6k plus 15. And which one is the simplified expression? I'm going to look for all of the like terms. 8k plus another k, that would be 9k's. Then take away 6k's, which would be 3. What is left, these are constants, no variable, 7 plus 15. 7 plus 15 is 22. And I see that that matches with B. For number 9, Samantha used the expression 6 plus 7h plus negative 6 minus 3h to represent the number of miles she ran in 1 week. Which of the following is equivalent to Samantha's expression? And I see many fewer terms than what was originally given, so I'm going to assume again that the like terms are being combined. See 7h minus 3h's, that would be 4h's. And then the constants that don't have variables, a 6 plus a negative 6, anytime you have opposites, they're going to cancel each other out and make 0. That's what the inverse property says for addition. Any number plus its opposite equals 0. Then we also know through a different property, the identity property, anything plus 0 equals itself, and that would match with A. For number 10, Tyler correctly combined like terms to simplify the expression below. 2y plus 5y minus 5 plus 8. Which expression could Tyler have written? I'm going to focus on the like terms, the y's. 2y plus 5y would be 7y's. I'm already suspecting maybe B, maybe C, maybe D. And then I see minus 5 plus 8. And right here, if it makes you feel more comfortable to rewrite the expression using addition, keep, change, opposite. We already said that the 2y plus 5y would equal 7y. 8 and negative 5 would be 3. 1, 2, 3, 4, 5 negatives. 5, 6, 7, 8 positives. These would cancel each other out in value, and there would be 3 positives remaining. And that is a match with B. If you were confused, I hope this explanation helped to clear things up. And you should also be receiving written feedback in an email along with the video explanation. Thanks for giving it a try. Excellent work.